So, hello everyone. My name is Kaan, and welcome everyone again for this beautiful day at the Solidity Summit, hosted by the Solidity team and the Argot Collective. We are also part of the Argot Collective, and I'll be talking about. I will be giving an overview of the current state of the source code verification, why it's close, painful, and ready to change, and what we are working towards doing that. So, the other day I was looking into the ERC 1155 standard, and I came across this forum post in the Open Zeppelin forum. Someone explains nicely what the ERC does, and very nice of them, they've written a contract and they have uploaded and deployed it in the Gurley blockchain, in the Gurley testnet. So I click on the links, and I come across this. So it's funny that we have this today in a massive Cloudflare outage, but this is unrelated to Cloudflare. This is permanent. And if you want to see a contract on the Gurley blockchain, you are greeted with this nice screen. Then I thought to myself, actually, on Gurley testnets, we have these contracts, but where are these contracts? Where have they gone? Like, are they in the graveyard? I mean, you can say this is a testnet, right, Kaan? Don't be too serious. But this reminds me and kind of indicates me what can happen also in the mainnet. So what do we do if this happens on the mainnet? And don't get me wrong, Ethereum actually has a good verification culture. The community demands contracts to be verified. We don't interact with contracts that are not verified, hopefully, right? And we have a good established culture, but we can do better. So yes, we can say the Ethereum contracts are open source, but the problem is they're open source through closed source verifiers, which doesn't really make sense. And then the dataset is closed. So of course, you can see the individual contracts one by one, and that's the whole point, right? Like, you want to see the source code of the individual contracts, but try getting those contracts and try getting a data set and try running benchmarks as Moritz has shown with a data set. Try searching contracts, or the verified contracts. So it's not possible with a closed data set. So we can do better, but before I will lay out and go into details of these problems. So the very obvious one is open source, right? We want everything to be open source. We trust only the open source software. And right now, the largest verifier is closed source. And as of today, the verification process is a black box. That means it's a black box. It's black box. It's not reproducible. And this needs to be changed and open sourced. So the other problem is the closed data. As I said, the contracts are accessible one by one. You can see them, read them, of course, that's the point. But the data set is not accessible. It's siloed. And for this data to be useful for data engineers, security researchers, or compiler engineers, for anyone that needs an overview of this data, right now this is not available. Maybe you have sourced this data somehow yourself by regularly checking the verifier, like scraping, but this is also not legal. But then the dataset is right now inaccessible. And the problem here is that the EVM data is on-chain. Yes, it's accessible, and anyone can build an explorer. So it's not a big issue if an explorer is closed source. But the problem is with the verified contracts, because the verified contracts are off-chain, and they're siloed. So it means you need to ask, and you depend on whose database these contracts are on. That's the main issue with the closeness of this data. And that also means when it's gone, it's gone. Right now, again, these two links are not available anymore. They're dead. And when it's gone, it's gone. And the last point is about tooling and the suboptimal DevX. I guess many of you here try to verify a contract once in a while, and it is not fun. And it's difficult to know why it fails, what went wrong. You need to get API keys. And also, we can do much better in terms of what we provide to the developers and the tooling. The current APIs have been there for a while, and they haven't improved. And we can actually provide much more data, like source maps, bytecodes, storage layouts, immutables, and the complete standard JSON input and output for better tooling. And the other issue is, if we leave things as they are, it's not going to change. So the current players are not incentivized to open up this data themselves. So someone has to do it. Someone has to push it. Not only push it, but also tell the community what's going on, and so that the community can demand this from these players. And in general, it's not a sexy thing to build. Like, contract verification is somehow taken granted. And there are more interesting things in the overall ecosystem to build on. It's not the frontier. So that means someone has to take this in hand and try to fix it. That's what we do at Sourcify, and also what we do with other verifiers at the Verifier Alliance. So Sourcify, shortly, was a Solidity side project within the EF. It started as a Solidity side project. Then within the EF, it became its own team. And now we spun out with Solidity into the Argot Collective. And since then, we are part of the Argot Collective, also as a non-profit organization, non-profit team, and we don't generate any revenue. And we are a 3-person team, and everything is done by me, Manuel, and Marco. We are all developers. Verifier Alliance, on the other hand, is the alliance we formed with BlockScout, RouteScan, and us, and also helped by Sam, if you recognize him. And in short, it allows easy and unified access to the source code of EVM contracts. And in the essence, it's a shared database. It's a Postgres database of all verified contracts that all verifiers have. So whenever Sourcify gets a contract, we verify it. OK, this matches. Then we put it in this database so that other verifiers can pull from it. For example, BlockScout then can look for a contract in this database and pull into their database. And the nice thing about it is we also publish this data daily in the Parquet format. If you haven't heard about it, Parquet is a modern data format that allows easy processing, mostly used by data engineers. So we provide this data in this nice format so everyone can make use of it. OK, and what are we doing to solve these problems? First, of course, we open source everything. Our main verification logic is open source. And the nice thing about libsourcify is it's a browser-friendly package. That means you can run it in your own browser and do the verification on your own browser. And this is actually what we do, what AutoScan does. AutoScan is a local first block explorer. It runs on Aragon, so you run an Aragon archive node, and you spin up a AutoScan instance very easily, and you have a local explorer that you can use easily. And it's, as I said, local first. But what you can do with AutoScan and Sourcify is you can fetch the sources from Sourcify. AutoScan already uses Sourcify to show the code. But in addition, you can fetch the sources on the browser, compile the contract on the browser, then do the verification once again on your own machine in the browser. So this allows you to make sure that actually the verification works without even trusting Sourcify servers. So we said the verification logic. Then we have other modules, such as the Sourcify server, the repository UI. And we also recently we took over the openchain.xyz. Many of you might be familiar with the openchain for the Ethereum signature database. We took the domain and the server over, and we implemented the same API. But we also enriched this data set. We took over the openchain data set. We took also the 4-byte directory data set. And we also added the verified contracts. So whenever a contract is verified, the signatures are already automatically in this data set. So you still can use the old domain, api.openchain.xyz, but over time we will be transferring this to the Sourcify domains. We also have a UI for this. And right now, you can see we have over 7 million signatures from different sources. And the next thing is the self-hosted Sourcify instances. Of course, Sourcify is open source. and we want people to run their own instances. And right now, we are aware of these 6 public instances from Hashscan, which is a block explorer from the Hedera chain, the Monad testnet block explorer, Ronin chain, Parsec Finance, VChain, and also the Walnut runs a Sourcify instance to verify contracts. Okay, so we open sourced everything. What is next? Then we verify everywhere. So we really believe this is key to open up this ecosystem. We believe a contract should not be verified in one place. It should be always verified in all the verifiers, because it doesn't make sense to have it in a single place when you can verify it in many places, right? So what we do at Sourcify since recently, I would say, when you verify on Sourcify, we also share this with other verifiers. So for example, you submitted us a contract, we verified it, but also you can see on our UI what's the verification status on other verifiers. So we also share it with Etherscan, we share it with RouteScan, we share it with BlockScout, so that users can also see what they do. But the limitation there is, with the Etherscan API keys, you can only post 250 verifications per day, regardless of the tier. Even if you have the most expensive API key, we are limited by this, so at least we can only share 250 per day with them. And of course, the second thing is the Verifier Alliance. So whenever we verify something, we post it in the Verifier Alliance database. We also listen to the database. So whenever BlockScout or RouteScan verifies the data, we also pull from there, and then we also verify it ourselves. Then we have built this Remix plugin. So previously in Remix, you had different plugins for different verifiers. You had a Etherscan plugin, you had a Sourcify plugin. We said, okay, like this really doesn't make sense, and it's very suboptimal developer experience. So instead, we built the unified verification plugin ourselves, and this now includes all verifiers by default checked. So whenever you want to verify a contract, it's already by default on all verifiers, except you need to add an API key for Etherscan, of course. And the next thing is the tooling. And recently, a couple weeks ago, Hardhat shipped the Sourcify support. And right now, there is also parallel verification for Sourcify and other verifiers. And Foundry is also going to support parallel verification or verifying on multiple places soon. And the last thing is opening up the data. We share the whole database daily in Parquet format, as I said, both the Sourcify dataset and the Verifier Alliance dataset on these URLs. So you can go to these addresses, to these URLs, and you will see a manifest file explaining how the data is structured and how you can download it. And right now, Sourcify has around 10 million, above 10 million contracts. This number is also similar in the Verifier Alliance dataset. And Sourcify has data from over 180 chains, 180 EVM chains. We also mirror this data in BigQuery and in Google, so that anyone using BigQuery can make use of this data openly. As you know, BigQuery works quite well in large data sets, but also nicely, you can pull this data set on a Jupyter notebook. I think on Google, it's called a Colab notebook. So you can spin up a notebook, pull the, I have a pointer, yeah, pull the data from our data set and do any data analysis you want to do. We also have a nice AI playground to showcase what you can do with this data. If you go to our website at Sourcify Dev, you will see this data playground. And here you can talk to an LLM from free models from OpenRouter. And you can say, for example, give me contracts with Solidity version 0426, or which contract is the most popular contract on the Sourcify datasets. And this will give you an SQL query, and you can execute this query on our BigQuery, the mirrored BigQuery dataset, and it will say, okay, the most popular contract is Gnosis Safe Proxy, and we have over 2.5 million Gnosis Safe Proxy instances. So this is to showcase and allow users to easily ask questions to the database and showcase like what you can do with this data set. And what else is possible? So the open data matters because it not only allows these, but also enables a lot of innovation in the EVM tooling. So with open data, we can do EVM tooling testing in bulk. Right now, for example, Nomic is making use of this data to test their compiler Slang. We can do data analysis on this. We can, for example, feed an AI model and train an AI model with this set of contracts. We can actually, the thing that I'm maybe most excited about is building a better decompiler. So I think right now the decompilers haven't been progressing that much, and with this data in hand, we can build much better decompilers. So if anyone knows how decompilers work or really excited about this, please find me and let's see how we can do this. Another thing is, and another possibility is to find vulnerability patterns. Imagine a security pattern is found. You can do a search on the whole data set and see which contracts are actually affected, and that would make things quite easier. So these are the only things that I can think about, top of my mind. I'm sure everyone in this room has different expertise, and I'm pretty sure this data can help everyone build better tools and use this more efficiently. So let's use this valuable data set to move EVM tooling forward. And hopefully, next time you see a contract, you ask yourselves, where are these contracts? Where are these actually? And hopefully they will not be gone for forever. So thank you. Happy to take questions. I guess we have some on the Q&A. If not, you can already scan this and shoot me some questions and catch me after the talk.
Actually, we do have questions from the app. The first question is, do your 4 bytes directory also register the error 4 bytes from new contract being verified?
Yeah, so we do have errors in the 4-byte directory. The thing is to maintain compatibility with the OpenChain API. I'm trying to find that slide. Oh, yeah. So to maintain compatibility with the OpenChain API, we don't have a specific error field. So when you get a response from the API, you will see a function and the functions, 4 bytes, and then events with 32 bytes. Because OpenChain didn't have that, we only have functions, but we mark them as error signatures in our database. So these are, for example, so if you give us a signature, the signature itself does not give any information if it's an error or if it's a function, right? You take the hash of it, you can use the 4 bytes or 32 bytes. But if it's associated with a verified contracts, looking at the API, we can say, okay, this is an error signature, this is a event signature, and that's what we do here in the left side or in the box. You can see found in a verified contract API, and these are the ones we marked as function, event, or error. But in short, you won't find the errors in the function field, in a separate error field, but you will find it in the function field.
Thanks, Kaan. Another question. Is the public shared Postgres database verified by a majority of Verifier Alliance, or does it take just one verifier to include a verified contract?
It has to be only verified by a single verifier, because in the database, we write the data, and we also write it's written by whom, so we know where it came from, and others are free to pull that data, but then it doesn't enter a cycle. So like it's only written once, and the first one that writes it, except the case when a contract is verified partially and it gets fully matched. So in short, I skipped this information, but there is an integrity hash at the end of the bytecodes, if you know that. So if we verify one contract without that, and then it gets later on verified with that, which gives us higher cryptographic guarantees, then we write it again. And that's a stronger verification.
Okay. Is there a good alternative to now deprecated contract sanctuary that can be searched or explored efficiently?
Sourcify datasets. I think that's the answer. We tried importing this smart contract sanctuary, but I think some either compilation information was missing, so we weren't able to import most of the contracts and verify again. And I also talked to Tintin, and we weren't able to do that. But I assume we have good coverage, and the dataset is already there, our dataset, and it's, I assume, probably larger than the smart contract sanctuary.
Okay. Does Sourcify plan to support IPFS?
IPFS. So we already support IPFS. I also skipped that part in this talk because I can't tell everything. So whenever you verify a contract, we pin those files on IPFS. And you can, if you're familiar with the metadata hash, the integrity hash I talked about, you can pull that metadata file from IPFS, and you can pull the sources from IPFS. But the problem with the IPFS hashes is you still need to verify them, right? Because I can't put whatever the hash at the end of the bytecode. So you still need to verify, even though you pull the sources from IPFS. So yes, we publish data on IPFS.
2 more questions. A little bit of a spicy question. Has Etherscan ever commented publicly about the concerns that you've raised so far?
So whenever this came up, at least on X, their response is we do provide contracts, and you can have it, the open source license contracts. But the problem is if you click on the link and get it, first it's not a data set, it's just a list of contract addresses, and it's like 5,000 contracts for mainnet, and you still need to retrieve them with an API. So it's not nicely formatted, it's not a data set, it's just a list of contracts. And I don't think saying we can't share non-open source license contract is a valid argument, because I would assume if you're publishing a contract, your very goal is to let people see this, right? And I think it's okay to have this in a data set. I think the licensing issues are around usage, how you're using this data, how you are reusing it. So, and even if that's like that, the data still should be formatted, and I don't think we have 5,000 contracts in the mainnet that are open source. So I'm not fully satisfied with that answer.
Another one to squeeze in quickly. When looking up 4 bytes with collision, do you share data about relative usage or presence of the different versions?
Can you repeat again?
When looking up 4 bytes with collision, do you share data about relative usage or presence of the different versions?
Nice. Yeah, so in the first iteration, we didn't ship that. So whenever there's a collusion, you have no extra information, except if there's a collusion, you get a extra field saying this is actually verified with a contract, but this, if you have a foo bar signature that is not on a contract, it's marked verified false. So this is the only information we have. But if we see people need more clear information around collusions, we can say, okay, like this signature has been found in 1,000 contracts, so we can say, okay, like there's a 95% chance this is actually the signature, and there's a 5% chance. I actually did a nice data analysis on the collusions, like around 1,000 signatures I found that are not spam, and you can check out our blog post about that, and it's a nice way to see how the collusion space is limited, and even if it's not spam signatures, we get around 1,000 signatures that they look really, real legit, and like unintentional collusions. So check out the blog post.
Here it says the timer has run out, but I think we have another minute before we need to start the next talk. How is Sourcify dataset verified? Do I need to verify it myself too after downloading it?
Depends on who and how much you want to trust. If you trust us, you don't need to. If you don't, you can spin up a Sourcify instance, do it yourself, or as I've shown, like Etherscan does, you can plug in the verification library we have and pull the data, pull the sources, and compile it yourself. But I think I would say the easiest way is to spin up a Sourcify instance and verify yourself.
And the last one, has Sourcify thought about productizing it, and in what ways, if yes?
Yeah, so as of now, that's something I think about. I would say for short term, we are not looking to productize it. I think the priority is solving the ecosystem problem. And once we think we have made progress on it, we might think about having this in a more sustainable way. But either case, our priority will always be having everything open source and all of the data open. So we will never silo, gatekeep, or close source things.
Thank you so much, Kaan.
Thank you.
Thanks for answering all the questions, and that was a super insightful session.